All right. So we're given a coffee cup calorimeter, which is a fancy name of saying styrofoam cup. And I have 60 milliliters of a 1.5 molar, that should say molar solution of sodium hydroxide combined with a 60 milliliter of a 1.5 molar hydrochloric acid solution. It tells me that the temperature of the solutions rise from 21.5 degrees Celsius to 31.1. And it asks us what the enthalpy of the reaction is. All right, well, let's start with the reaction. I'm going to write that down. Oops, put on my pen. So I have sodium hydroxide in solution reacting with hydrochloric in solution. What kind of reaction is that?
Double replacement.
You can view it as a double replacement, also as a neutralization or an acid base. Yep, absolutely. So what will my products be? What do you think, Lily?
Water and sodium chloride.
Good, water. Water and the salt sodium chloride, beautiful. Okay, and ultimately what we're looking for is this delta H, the change in enthalpy of the reaction. All right. Well, I'm given a volume of the sodium hydroxide and a molarity. And I'm given a volume. See, this is where the finger of the acid. I'm given that my TI is 21.5 degrees Celsius and my TF is 31.1 degrees C. So if I draw a picture, because I like pictures, there are two solutions and I mix them. And I end up with 120 milliliters of the solution, right? Here's how I represent a reaction that happens in solution, right? I'm going to draw a little blob within my solution, and that represents my reaction. Does it really do that? No. No. These particles and ions are spread out throughout that solution, and it's happening all throughout those 120 milliliters of solution. But it's easier for me if I represent that reaction just with a little blob. Can you tell me which direction that heat of the reaction is flowing? Is it going out of my little blob of reaction into the solution, or is it going from the solution into the little blob? Jake? It's going out. How do you know that?
Because the temperature raises
Good. The temperature of what raises?
of the solution.
Good. Temperature of the solution raises. So remember that you're probably measuring this with a thermometer, right? So you are measuring the temperature of the solution, and the solution increases, so that Q is flowing into the water. Okay? That makes sense? All right. Do you have enough information to calculate Q? What equation would you use to calculate just the Q of the water? Because really what I'm going to look at first is the Q of the water. What equation might I use? I'm going to use a different colored pen. What do you guys think? Chris, we have a thought?
Q equals MC delta T.
Oh, I think that's a good place to start. So Q is equal to MC delta T. What am I going to use for my M? They just told me 120 milliliters. They just said 120 milliliters. Can I use that to convert from milliliters to grams? So what's the mass? 120, right? Grams. My heat capacity is going to be the heat capacity of water. And I know that my it raises from 31.1 degrees C from 21.5 TF minus TI. Okay, and if I do that, I get 4,815.36 joules. Does that all make sense? All right. Well, how is that Q of the water related to Q of the reaction? How's the Q of the water related to Q of the reaction? What's that? It's opposite. Is it the same quantity, though? Or?
Yes.
Oh. Do you think you should probably write that to make sure that I understand that you understand that thinking? There's a lot of understanding in that sentence, right? So negative Q of the water is equal to Q of the reaction, right? Because the heat let off by the reaction was what was absorbed by the water and made the water temperature go up. Okay. So this is going to be equal to negative 4815.36 joules. Well then, how's Q of reaction related to the enthalpy of reaction, that delta H?
Is it moles times delta H?
Yes, beautiful. It is Q of reaction is equal to, gosh, I'm getting sloppy, N delta H of the reaction. Oh. And the question said per mole of acid. Can I calculate the moles of acid? Annalise, what do you think? Can I calculate the moles of acid?
Yes.
How do I do that?
You're going to take the 0.06 liters of the acid, and then you're going to use the molarity to figure out the moles.
Ah, cool. Chemistry's so cool. I have to remind you guys of that fairly often. Not really this class, though. And I get that right, 0.09 moles of HCl? Oh. Oh, well then it is, oh. So now, finding delta H, that's a delta, geez, H of reaction, is really just equal to the Q of the reaction over N. If you guys write that messy for me, I'm going to be upset. So negative 4815.36 joules over the 0.0900 moles. And you should end up rounding to 3 sig figs, 53.3 kilojoules per mole of HCl. Question?
Why isn't it negative?
It is. Yep. So the reaction itself, endothermic or exothermic?
Excellent.
Exothermic. Okay, the reaction itself is exothermic.